Infrastructure as code is a trend that has been popularized over the past decade as cloud computing and distributed systems have become part of every technology company. Tools like Salt, Puppet, Chef, and Ansible allow us to manage servers and processes from the command line. David Boucha works at SaltStack, the company that makes Salt. Salt is a platform that provides configuration management and remote execution. In our conversation today, we discuss how the distributed systems architecture of Salt works and how it can be used in practice. We also discuss infrastructure as code in the context of modern infrastructure tools like containers and Kubernetes. If you enjoyed today's show, please share it on Twitter or Facebook, or share your favorite episode with one of your friends. It really helps the show grow. Word of mouth is the best way for the show to grow. Also, you can send me an email at softwareengineeringdaily@gmail.com anytime. I'm always looking for feedback. I'm always looking for new show ideas. And we're coming up on the 1-year anniversary of Software Engineering Daily, and I am showing no desire to stop. So keep sending me your feedback and your ideas. And thanks for listening to the show. Software engineers never stop learning. If you are listening to Software Engineering Daily right now, you enjoy learning so much that you listen to a podcast about technical software topics. IT Pro TV has videos for people like us, people who never stop learning. I'm using IT Pro TV right now to learn about Amazon Web Services, and I found 10 hours of high-quality videos about EC2, elastic load balancers, orchestration, cost management. If I ever decide to start my own tech company, I will need to know how to manage the cost of my servers. Go to itpro.tv/sedaily to get started with a free 7-day trial of videos. You can then use the promo code SEDaily and get a 30% discount, and that discount is permanent. Watching these videos, I have learned how to configure auto-scaling groups together with load balancers. I've learned how to configure a database that can scale up without inconsistencies. If I wanted to test out of the Amazon SysOps certification right now, I could. There are also courses about Microsoft operating systems and networking, VMware virtualization, Cisco routing. You can watch 70 hours about Cisco routing and switching, and it is engaging and entertaining material. If you listen to Software Engineering Daily all the time, this is the kind of material that you will love. You can put it on in the background, and you will find yourself just absorbing the information without even realizing it. You can try it free for 7 days. Go to itpro.tv/sedaily. Use the promo code SEDaily to get 30% off, and after you try it free for 7 days, I have no doubt that you will want to continue to invest in yourself and your future. Thanks to IT Pro TV for sponsoring Software Engineering Daily and for producing this top quality content. David Boucha is a senior engineer with SaltStack. David, welcome to Software Engineering Daily.
Thanks, Jeff. Great to be here.
SaltStack is a platform for configuration management and remote execution. So let's start by talking about the first one, configuration management. For those who don't know, what does that term mean, configuration management?
Configuration management is a general term for tracking and managing the configuration of both the operating systems on your servers as well as the configuration of the applications themselves.
So with SaltStack, I can define my different nodes, the different computers in my distributed system using this configuration management. Give me a few examples of different types of nodes, different types of servers that I would want to define using Salt's configuration management.
Well, let's say your infrastructure requires multiple different types of applications. So maybe you have a JBoss server that's running some Java application, and maybe you have a Redis server that's used for caching, and then maybe you have an RDBMS, so you have Postgres that's running there. And so you could define inside of your what we call salt states, you can define exactly what software packages, operating system packages, the configuration files, the contents of those configuration files, and deploy those to all those separate machines. And one thing that's nice about why Salt does that, it's very easy to say you have a development environment where all three of those are on just one server for development purposes. So you could use those same Salt states to get everything configured just right, work on your development. And then once you move to QA and production, then you could then split those out into separate servers or clusters of servers as needed and still use the exact same configuration states for those different scenarios.
SaltStack is also used as a distributed remote execution system. So this means that through Salt's interface, I can run commands against any of the nodes on a cluster. Give me a few examples for how this remote execution could be useful.
Well, this is a really powerful tool. In fact, when I first started using Salt way back in the early days, that was what got me most excited about Salt, actually. Pardon me. So when I first started using Salt, I was able to finally check the immediate current status of all my servers immediately. So I could run a command and look at the output of all my disk usage and compare that across all my different servers and get notifications of when something was out of whack. I can, for example, when we have there's some new, OpenSSH bug and I want to run a command to find out which of my servers are vulnerable, I can easily run a command and immediately know exactly which servers are vulnerable and then run the commands to remediate that problem that I'm seeing. Other situations, for example, for software auditing, and say you're in a Windows environment and you want to know exactly how many copies and which versions of Adobe Photoshop are installed across your infrastructure, you can run a command and immediately find out exactly what is actually installed out there, not just what's in some database or a spreadsheet or what people expect to be out there, but what is installed right now. And to be able to run those commands and get that feedback immediately was just powerful as a system administrator to be able to see and have that visibility into a live infrastructure was a really powerful thing for me.
So it's not at all surprising that we need a distributed systems management tool like SaltStack today, but this was not always the case. When did we start getting to the point where every company, every stack needs some sort of distributed systems management tool set?
Well, as companies have grown and infrastructures have grown, you've seen a lot of distributed things across the world. So people will have data centers, even small server closets and things in different facilities. And to be able to run those commands and manage all those has become a really important tool. So in a previous life, previous jobs, when I was working for various government agencies, we had servers and things all around the world that we had to manage, and it wasn't always easy to remotely find out what's going on and remotely make changes that we needed to have happen.
So at a high level, the architecture of SaltStack is fairly simple. There's a master server that is able to send commands out to other servers, which are called minions. So give me a little more explanation for how this architecture works. What is the interaction between the masters and the minions?
Great question. So Salt's actually even more flexible than that, but that's kind of the default setup. So you have your Salt master server that all your minions then connect to that Salt master server, and they connect to a ZeroMQ publish port and wait for commands. So, that's people will use Salt in this scenario with 4 or 5 servers, and then we have other people that will use Salt in the scenario with 27,000 servers connected to their master. So it's a real wide range of types of people that will use Salt. Sometimes people have a small, Django website, maybe has a web server and a database backend, and Salt allows you to manage that very nicely.
And so this master and minion architecture, it's pretty flexible. It's hierarchical. You can add masters over masters that you already have in place. Give me a picture of this hierarchical server architecture and why this is relevant.
So what you're referring to there is the Syndic. So a Syndic allows you to, like you said, have a hierarchical level of masters. So you can have one master that's kind of like can see everything across your infrastructure worldwide, and then lower level masters that can see minions that are just connected to them. And there's several different situations why you would want to do that. One fairly common one that several large organizations will do is they have, sometimes these companies will have a large or a central IT governance group that's basically kind of in charge of everything, all the technology, making sure security is done properly. But there might be subgroups that do this. So they use this, for example, at the Jet Propulsion Laboratory in California. So the higher level central IT group has visibility down into all the lower minions. They can run reports to find out if there are certain versions of software that's vulnerable. So if there's an Apache vulnerability that came out, they can run a command and find across all their servers, across their entire infrastructure, if there's any vulnerable version of that software out. But that also allows the individual business groups to have their own developers. They might even be quite separate from other business groups. They can have their own Salt Master that they can manage the security, manage all the infrastructure in their little area, and not be lumped into the same infrastructure as other groups that might not be related at all. Other places will use the Syndic infrastructure to spread out to manage things across their infrastructure worldwide. So maybe you have 5 worldwide data centers. You could have a Salt Master in each of those data centers that manages everything locally, and then you could have a higher level master that can reach out into all those different data centers, talk to those masters and the sub-minions below those, and gives you kind of that distributed infrastructure and visibility worldwide just from that top-level master there. In addition to that, so again, Salt's very, very flexible, but kind of a philosophy that we try to avoid making a system administrator or an architect try to avoid making that person bend to what Salt needs. So the Salt minion can actually run masterless by itself. For example, at Lyft.com, they will use an auto-scaling environment, and when a new server will come up, we'll have the Salt minion installed already. It will run, and it will pull its configurations from some external sources and run everything locally just by itself. So for example, on those servers, they don't ever actually communicate with the Salt Master. They just get their configurations from an external source, run everything locally. People will do that on their laptops as well. And then we also have, instead of the constant communication over ZeroQ, we also have a interface we call Salt SSH that allows you to set up an SSH connection that is just temporary for the length of the configuration that you're doing, and then that connection is shut down. So if you have say you have a Django app that's running, you don't necessarily need to have constant communication with it and everything. You just want to make a change to your code, deploy that code, and then be done with it. And then Salt SSH allows you to do that. So there's a lot of ways you can use Salt and make it work according to your specific needs on your infrastructure.
Okay, so I want to come back to the idea of remote execution and get an end-to-end description for what happens when I submit a job to SaltStack.
Okay, so in the typical environment where you have a master and minions, the minions are listening on a pub port on the master. It's a ZeroQ pub sub interface. And a typical command you'll call salt, and then you have a target, and the target can be asterisk for all your servers, or it could be you could target certain subsections of your infrastructure. So you could say, I want all my Ubuntu servers that are that have 2 gigs of RAM or more, and whatever criteria that you want, and then you pass out a command to execute. So when the minions, when they're listening on that pub port, they'll see the command is published, and they'll evaluate whether or not they match the target that was there. So in that scenario I just described, if it was a CentOS server, it would just skip that, would not execute that. But if it did match that target, then that minion would then execute the command that you specified. Once that command is completed, then the minion will then return that data in a JSON serializable format to the master, which then you can see on the command line, and you can review the output, see if there were any failures, see what changes were made. In our enterprise GUI, then you would also be able to see that in a nice way there, see which servers had errors on them when they ran that command, and that type of thing.
Okay, so what happens when a node fails? So I get all these nodes are connected through 0MQ. So what happens when like a minion fails or when the master node fails?
So when you're talking about a minion failing, are you talking about the entire server failing or the salt minion daemon?
I guess take me through both cases.
Okay. So in the case the entire server fails, then that minion would not see the job or any jobs that were sent by the master, and so it would never see that job. So the jobs that you send out are ephemeral. So if the minion's not around to see that, it won't pick that up later. It will when the minion comes back up, or if you rebuild that, then you would send those jobs back out to it as well. In case there was a problem and the salt minion daemon itself died or crashed for some reason, the server would still run. The application would continue to run as it was last configured. You just wouldn't be able to, if the salt daemon wasn't running, then you wouldn't be able to send commands to it through the normal interface. A lot of people will set up salt SSH for the situation, so they have like a secondary backup in case they do need to push a command out through SSH and fix any problems like that.
So there's a system in Salt called the reactor. Could you explain what the reactor does?
Yeah, the reactor is part of a really powerful event-driven interface that Salt has. So because we have this really rich flow of data back and forth between the master and the minion, you can take advantage of that information. So there's what we call the event bus. So things that happen on a minion, for example, every time you you execute some command, you apply some salt states, and various other things. Events are sent from the minion across this event bus up to the salt master. The reactor is one tool that allows you to listen to events that are coming on the event bus. And so, for example, let's say you could set up a reactor that would listen for a key acceptance. So if you accept a new key for a brand new minion, event is sent for that. You can have a reactor that then sees that new key acceptance and then does something. Maybe register that minion ID in some database somewhere, throw some information in your CMDB, maybe run some commands on that new server, maybe to configure it, set up SSH, set up security, kind of the sky's the limit. Whatever things you need, the reactor could do that. You can also have the reactor do things. Let's say you have an application that you don't have much control over, and it constantly goes up, increases memory usage, and then you need to restart that service every once in a while. You could just set that to restart every night at midnight, but maybe there may be some repercussions for that. So we have a thing called a beacon that runs on a minion, and a beacon can check for the status of something and send an event. So we have a memory beacon and a load beacon. And so if the memory passes a threshold, it can send an event up the event bus, and the reactor can see that and say, oh, when this service goes beyond this threshold of memory, then we need to restart that service. And then bam, it'll do that. And instead of having to manually check that all the time, you can have that restart that service and then maybe log that in your monitoring system somehow. Same thing with disk usage. Maybe if you get past a certain threshold disk usage, you can have a beacon check for that, every minute or every hour or whatever you feel comfortable with. Send an event up the event bus. The reactor goes, oh, hey, we have a server that's beyond 80% in our disk usage. I'm going to send a notification to our CMDB so that can be checked by a human and find out why that's happening, or if it's a known situation, request whatever remediation needs to happen for that.
So I can also use Salt to set up continuous deployment, which I can do by setting up the master node to talk to my Git repository, and then I can configure the system to respond to a code push by running automated tests across the system. Can you talk in more detail about how I would set up continuous deployment and use continuous deployment with Salt?
Yeah, there's quite a few different ways you can do that. One that's fairly common is that they'll have a Jenkins server that will test new commits, that type of thing. And if all the tests pass, then the Jenkins server itself can send an event on Salt's event bus and say, hey, this Git tag has passed all of our tests, and deploy. And if that does, when the Salt master sees that through the reactor or possibly an engine, then you'd have your deployment routines already set up so that you could push the code out to all the different servers and then go through whatever deploy process you need to do that. And so what's really powerful about that is that your developers can make their changes, push their changes to Git, and then have a little test run, have successful tests pushed out, and just have that constant deployment where you're deploying multiple times a day based on these successful testings, and that allows your developers to have that desirable quick feedback with their changes without having to give them keys to their entire infrastructure. So they don't have to have root on all your production servers. All they have to focus on is just making sure their code passes all their tests in Jenkins, and Salt just knows how to deploy that for them.
So when you're working with this distributed set of production servers and you have, let's say you have a new version of software and you want to deploy the code to a single server in order to test the code against a small fraction of users, this is known as the Canary deployment. So this is another usage that I can take advantage of Salt for. How can I do Canary deployments with Salt?
So that's actually really, really simple. There's a couple of ways you can tag or give a piece of metadata to a server. So you can set that up centrally in what's called Pillar, where you assign certain pieces of data essentially there, or you can set that in what's called grains, which are where the minion or the server itself is kind of the source of truth, and you would just tag that. You could say Canary is true, or have a list of roles, and one of those roles could be Canary. And then your target, when you run a command, would just include a target of role Canary, and then maybe that's 5% of your infrastructure or whatever you decide that could be. Only those would receive or execute those commands that you wanted. And you could actually do that if you wanted to have like a slow rollout. So you could say, you could have different levels of Canary. So say you want to start with just 5%. You could have, a certain number of those that are your, Canary group 1. If that seems fine, you want to start spreading that out, move to, 25 or 50% of the infrastructure as you slowly, build load on these servers. So it makes it very easy to kind of slice and dice your infrastructure like that, so you can slowly deploy that as needed. So maybe you won't see a problem until you really are under a very, very heavy load that you will only see in production, and you can test for that with Salt very easily.
So let's say I'm building my company and I'm using Salt as my distributed configuration management and remote execution tool, and I'm scaling up my business to thousands and tens of thousands of compute nodes. What are the kinds of bottlenecks that I'm going to begin to hit with Salt?
Well, once you get up to 4,000 or 5,000 nodes, there are quite a few little flags that you can modify on your Salt master to start allowing to scale up. So there's things like the high watermarks in your zero queue queues. There's also the number of worker threads and things that Salt uses to manage a load. At the higher levels of number of minions, some things just like the sheer quantity of data that's just being sent back to the master all at once can be, quite difficult to deal with. So, LinkedIn, I believe, is running something like 25 or 27,000 minions against one Salt master. Of course, that Salt master is an incredibly beefy machine to handle all that. But a lot of times people will end up using multiple Salt masters because generally speaking, there's not a whole lot of companies that are at that scale that have 500,000 servers in one data center. So a lot of times there's even facility and network considerations and even political internal company reasons to have separate Salt masters that kind of helps you to scale out laterally. Our Salt Enterprise API as well sits above your Salt masters. That also allows you to scale out to some of these larger nodes. But for most companies, Salt handles scaling from 2 or 3 servers all the way up to 6, 7, 10,000 servers without any problem. And there's just a few tweaks to make when you get to that kind of stage.
So you mentioned LinkedIn scaling to like 27,000 nodes. What kinds of things is LinkedIn using Salt for? Are there any unique usages that you can share that LinkedIn uses to take advantage of Salt?
Sure. They've been pretty open with a lot of what they've done. They've spoken at our SaltConf for several years now, describing a lot of things that they're doing. But they're using Salt for a lot of the typical things, managing their configuration of their servers, deploying code, just all those basic things, really. I don't think there's anything really magical about specifically what they're doing.
Okay. Well, so what about with data warehousing stuff? Like, would they take advantage of Salt to manage Hadoop jobs, or would they do that with something else?
I'm not sure. Because they're such a large organization, they have different teams that do a lot of those different things. So I'm not sure about LinkedIn's usage of Salt with their data warehousing specifically. But I do know a lot of companies use Salt to manage their Hadoop jobs, they'll spin up, look at requests from a scientist where they want, 400 new servers in a Hadoop cluster, and they use Salt and Salt Cloud to spin up VMs and give them that infrastructure. So that's used quite a bit. The academia and even actually the large banks, trading firms, again, the academia that are working with big data love using Salt because they have so many servers that they're managing and all these different clusters, and they can run these commands quickly across all those infrastructures. They don't have to make a change and then wait an hour for those changes to kind of filter out to their infrastructure. They can make that change and then have it affected and get those results back, in just a matter of a few seconds. And so, we're heavily used in governments, large training firms, big banks, and a lot of universities for those tasks.
Software engineers are always looking to automate their work. Software automation lets us get more done with the same number of resources. Investment automation works the same way. Wealthfront is an automated investment service that relies solely on software to acquire and manage client accounts. Traditional investment services have many humans in the loop, advising clients and taking fees. The problem with these older advisory services is that the advice that these services are applying is often so systematic that a computer could give the same answer, or an even better answer. Wealthfront takes a new approach with software-driven automated investment that provides better returns through software engineering. Go to wealthfront.com/SE daily to get a special offer for our listeners. $15,000 managed for free when you open your account. Don't pay commissions and account fees. Maximize your gains with Wealthfront's Set It and Forget It investment automation. Check out wealthfront.com/SE daily. It would support Software Engineering Daily, and it would also introduce you to the world of automated investment, so you can see if you like it or not. Wealthfront.com/SE daily. Thanks to Wealthfront for sponsoring the show. You've been a loyal sponsor, and we really appreciate it. Now let's get on with the show. Salt is part of this movement of infrastructure as code tools, which includes tools like Chef and Puppet and Ansible. Explain why these infrastructure as code tools started getting created.
Well, there was a need to, especially in the config management portion of things, to know exactly what's been deployed, how it was deployed, and how to reproduce that. So when you had a small number of servers, typically you have like just one person that would just kind of be your server guru, and he or she would configure your server and get it running, kind of get it dialed in, and then that was kind of that. And so you run into the situations, and everyone's probably heard of them, where there's some critical server that's been sitting in that server room for 6 years, and the person who built it is, they've quit, they've got another jobs, and nobody really knows how it was set up and what parts are critical and what's going on. And so nobody would touch it. And I've even heard of places where they would image that server and put it on new hardware and just run that server again on the newer hardware using the image they took of the hard drive, because they just couldn't, they just didn't know what was going on with that server. Using a config management tool allows you to define, for example, in Salt, in a very clear way, exactly what should be on that server, what packages are there, what code is deployed, and what all the configurations are. And you have that in a very succinct, clear, textual definition. And so if a server dies or you need to add new nodes to that server, you can take that definition and create a new one. That also helps manage the life cycle. So as the developers and system administrators need to make changes to those servers, you can keep those salt states, that definition in Git or whatever source control you want, and you can see those changes through time. And so if you make a change and that causes problems, then you can just revert that in Git and then redeploy with the proper code there. It's a real common thing to have some kind of a problem, and then so a developer logs into production system, they tweak a couple config values, and then it solves the problem. But then everyone forgets what changes were made. And so if you have a disciplined config management solution, you can take those fixes, record them, and make sure they're reused if those systems gets rebuilt or duplicated or reused somewhere else. So that was a really important thing. And that's why Puppet, Chef, and later Salt came along to solve.
What are the differences between these different tools? Because you often hear them getting lumped together: Puppet, Chef, Salt, Ansible, etc. What are the differences? They must be solving slightly different problems, at least.
Yeah, I think the biggest thing is you really should be using some tool. So if you're not using a tool or you're using something homegrown, I think you're really making your own job harder if you're not using a tool. As far as Salt, one of the things that's different about Salt is that remote execution was not an afterthought. When Salt was first written, the very first thing that was written was the remote execution. Having the ability to get the status of your servers, run commands on them very quickly was something that's very, very different. Everything else that Salt does basically works on top of that remote execution system. So that's something that's quite different. In fact, places like Wikipedia and others will use Salt to deploy their Puppet manifests or execute their Chef modules. So, for example, at Wikipedia, they had something like 35,000 lines of Puppet manifests, and they just didn't have the resources to go through and change all those out to Salt. And so they would use Salt to deploy code and then execute their Puppet runs to do all the configurations, and use Salt to do that orchestration the piece of it. So that's a pretty common use case. If you go look in our code base, we have modules to work with Salt, with Puppet, with Chef, with Ansible. Salt's a very pragmatic tool, a very pragmatic company. So there's almost no large company or organization that we work with that just completely uses Salt or completely uses one tool, because a lot of times there's just history, there's personal preferences within the company. And so Salt works really well with all these different tools.
Interesting. So you're saying that these can be complementary tools rather than mutually exclusive.
Absolutely.
Many architectures today are not just composed of servers. The servers have gotten sliced up into Docker containers or other containers, Rocket. So can Salt be used to manage these containers? Absolutely.
So the whole containerization of the tech world is people still kind of figuring out the best way to do that. There's a lot of tools out there that do that. But generally, unless you're like a brand new small company, there's very few companies that are completely containerized. So having Salt being able to straddle your older infrastructure that's still going to be around for a while, as well as be involved with new infrastructure, is a really powerful ability. Salt, because it's allows you to do this orchestration, and you can build applications on top of Salt, allows you to do some interesting things. So, for example, I have a demo where I load up a bunch of different web servers in containers, in Docker containers. And then because Salt has the ability to inspect your infrastructure, in this example, it would spin up an AJ proxy server and then find out which Docker hosts were running the web services that I wanted. And so I get the IP address of the Docker host, as well as the port that container was running on, and then have AJ proxy directly to those containers. People will also use Salt to create their Docker containers. I believe Lyft is doing that as well. So instead of having all their configuration in Docker files, which is basically just bash, they will use Salt to create the container to their exact specifications, and then create that an image based off that container. So there's a lot of ways that people are using Salt with different types of containers, Docker containers, Rocket, as well as Lexi containers as well. And so we really like being involved in that space. It's definitely, where a lot of investigation and progress is going towards. So Salt's definitely involved there.
And as we look towards the future of continually containerized architectures, there are these full container management tools like Kubernetes or Docker Swarm. There's other container management system tools, Mesosphere, that it seems like these manage the full container story. Do these systems interact with an infrastructure as code tool like Salt as well?
Yeah, a lot of them do, because you're defining your configurations for those. In fact, Kubernetes uses Salt under the covers. In fact, one of our employees, Seth House, actually had the first non-Google commit to the Kubernetes codebase when he updated the version of Salt that they were using. So yeah, they use it under the covers for some operations, not everything, but for a few things. So there's definitely a lot of tools that kind of maintain the whole life cycle for that, and so there might be places where Salt may or may not be used directly in there. But there's also very few places where everything is containerized and everything is directly tied into that. So, as these tools get built out, there's modules for Mesos, and there's modules to work with Kubernetes and things, and so there's definitely room for Salt to be of use in those types of infrastructures.
What are the types of things that I would get with Salt that I would not get with whatever the Kubernetes? I forget what the Kubernetes command line. I think kubectl, whatever. Just the things I can do from the Kubernetes command line.
Well, so Kubernetes is basically the experience of Google using containers for the last however many years, kind of condensed into that package. So there's a lot of lessons learned there. One of the powerful things about Salt is that Salt makes it very, very, very easy to add your own specific functionality on top of Salt and deploy that and use that functionality. So with a tool like Kubernetes, once you get that figured out, even deploying Kubernetes, making changes to that isn't going to be as simple as adding a new Salt execution module or extending Salt to do exactly what you need. So people use Salt to deploy Kubernetes, to get that all set up and configured, and Salt makes it very easy to connect into Kubernetes. So maybe there's other tools, other systems that you're using. Salt will make it very easy to communicate with Kubernetes and interact with that in a powerful way.
So many companies today are built on public clouds like Amazon Web Services, and the public cloud companies like AWS or Google's compute platform or Azure from Microsoft, it seems like it would make sense for these companies to build. They build a platform as a service on top of their infrastructure as a service offering, and it would seem like their configuration management and the remote execution tooling that they would build on top of their platform as a service would be more amenable to their own architecture than something like a Chef or a Puppet or a SaltStack. But in actuality, there are plenty of people who are using these kinds of tools on top of their servers on AWS. So why is that the case? Why didn't these infrastructure as a service providers, platform as a service providers, why didn't they build? Why doesn't their tooling do the job of the infrastructure as a code tools?
I think it's a matter of focus, and they've pretty universally created APIs that allow their users to kind of do whatever they want. I think AWS, they basically want to be able to be a partner with whatever tool their users want to use. So AWS has actually done a little bit of that, but we have good relationships with Amazon, Rackspace, and Microsoft and Linode and Google Cloud Compute, and they're just really happy to have their users have good access with whatever tools that they're using. And Salt actually allows you to work in a cross-cloud way. So I have demos that I run where I spin up virtual machines on 5 or 6 different cloud providers, set up network configurations and DNS configurations, and run clusters of software, across cloud and that type of thing. So, Salt's very, I think we support something like 19 different public and private clouds that people use, and allows you to have that cross environment, so that people don't get locked into one specific provider.
So why is that a practical idea? So some listeners that may sound really weird to them. Like, why would you want multiple clouds? Why would you want to manage your infrastructure across AWS and Google and Azure and Rackspace? Why would you want these multiple providers on this for the same application?
So I've seen several different reasons for our users. One is sometimes there's historical reasons why you're in one cloud, and then later on there's business reasons why they start migrating to a different cloud. And so usually there's a lag there where they're just split across clouds because it takes time to make those changes. But there's also cost considerations. So one of our customers has a significant footprint of their own data centers and infrastructure, but they wanted to be able to convert some of their costs to be temporary costs, and not have to build out new infrastructures quite as frequently. And so they would burst some of their actually 3 different clouds based on pricing that they got from those different cloud providers, based upon performance characteristics of the different cloud providers and features that are available. And so that allowed them to save a lot of money when they needed to increase their capacity, but maybe only for a few hours or a few days. And instead of having to have all this excess capacity in their own data centers, they could do that by bursting on the clouds. Other places will also use it for disaster recovery. So if pretty much all cloud providers at different times have had serious, catastrophic issues where it's just down, and they're definitely improving in that area. But a lot of companies do feel more comfortable having the ability to use different clouds for disaster recovery purposes and that type of thing. So there's a whole variety of reasons why that happens.
Right. So you go beyond the multi-data center approach to the multi-cloud offering approach. So we hear this term DevOps often in the context of tools like Salt and Puppet and Chef. And we've done a number of shows about DevOps. There's a lot of confusion, a lot of ambiguity, different definitions around this term. What does that term mean to you?
Well, to me, DevOps is just a tighter collaboration between developers and the systems administrators and architects. And basically, I believe it helps create a better product, a more reliable product when the people are working on the same team, as opposed to shifting blame, that type of thing. So within Salt, we work with thousands and thousands of people that all have differing versions of what DevOps means, and so we actually try to be very agnostic as far as that goes. And so people use Salt for their different DevOps operations, and they're able to use Salt in a way that works great for their organization, because there's probably tens of thousands of different versions of what DevOps means to the company. And then in the end, for us, for Salt, that's really what matters, is how Salt can be effective for however a company has their DevOps organization set up.
So let's talk more about SaltStack, the company itself. Tell me how development of the product of Salt goes on at the company, how you guys manage different teams and how the organization is managed.
Well, we're kind of an interesting company because we do have somewhere around 60 employees at this point. Our Salt is developed hand in hand with all of our users and customers around the world. So in the course of a given day, we will have new features, new bug fixes, support requests, issues opened from people literally around the world. In the course of one day, I'll be talking with a Salt user in Hong Kong, a packager in Australia, a Salt employee in Portugal, and someone else in Russia. I mean, it's literally worldwide. And within Salt, we have SaltStack, the company. We have several teams that kind of focus on certain things. So we have a platform team that does things that are specific to a certain platform. So like packaging for Windows, Mac, all the different Linuxes, that type of thing. We have a core team that handles all the pull requests that are coming into Salt, core development, bug fixes that are related to core pieces of Salt, that type of thing. And then we also have a team that is working with all the different cloud providers, making sure our cloud modules work well, working with the Salt proxy, which communicates with switches and things like that. That team kind of handles that. And then we have a QA team that manages all of our Jenkins servers, that works with both Salt employees and our community to continually add new, more and better unit and integration testing for Salt. And so we try to maintain a really good communication between all those different teams so that we're on the same page and working smoothly. So there's again the working with the community and our Salt team, and we have Salt employees that are here locally in Utah. We have a lot that work remotely, and Salt's just built to kind of work in a distributed manner.
What's the business model of the company?
So our income comes from a few different sources. One that we do a lot of is we provide support contracts for companies just on open source Salt. So if you have 5,000 servers and you're running Salt and you'd like greater access and priority support for Salt, we provide that. We also do on-site and remote Salt trainings, that type of thing. And we're actually also very close to releasing our Salt Enterprise API, which is a system that sits above your Salt masters that allows you to do several things. One, allows you to scale across multiple masters and grow your infrastructure to larger numbers of minions. And also provides a really nice GUI that makes it really easy to drill down and to see where trouble spots are, do reporting, security reporting, and various things like that.
What's in the future for Salt? Where is the company headed? What are you working on? What kinds of big engineering initiatives?
So right now, the number one is the Salt Enterprise API. It's actually very close to being released. But we are going to continue our integrations with various operating systems. So this last year and a half or so, we've made a big push to improve our Windows support, supported Windows DSC, Microsoft Azure. We have a lot of Windows users, and Salt works fantastically on Windows, and we're going to continue that partnership there. And also, we've been partnering with a lot of improving our integrations with different operating systems, like, for example, like OpenSUSE, partnership with Microsoft, closer working with Ubuntu and things like that. So basically, Salt development is driven both by kind of some of SaltStack's internal goals to provide security auditing, that type of thing, but also by the community and what they desire. So our community will make requests and also provide features as well. There's plenty of features within Salt that we didn't think of, but a community member really needed something, and they added that in. So that's always a factor.
Cool. Well, David Boucha, thanks for coming on the show and talking about SaltStack and infrastructure as code. This has been a great conversation. I really appreciate you coming on the show.
Thanks, Jeff. I really enjoyed it.